Very pleasant morning to you, dear children. Today we are going to continue the same lesson, the modern periodic table, and we are at the last part of the chapter. We were discussing about the trends in properties. So how the properties change when we move from top to bottom in a group and from left to right across a period. And in the last class we discussed two properties. They are valency and atomic size, isn't it? Okay. And we know that the valency does not change when we move from top to bottom in a group, as the valence electrons remains the same. What about in a period? The valency first increases 1, 2, 3, 4, then decreases 3, 2, 1, 0. And the atomic size, we know that across a period from left to right, what happens? The atomic size decreases, and in a group the atomic size increases. Alright. So today again we are going to discuss two more properties. They are metallic character and non-metallic character. How these two properties change from top to bottom in a group and from left to right across a period. Okay. So let's move to metallic nature. Property number 3, metallic nature. So what is metallic nature? The nature, the character of metals, isn't it? What character is shown by metals? We know that metals are ready to lose electrons, isn't it? So metals are ready to, or you can write metals lose electrons. Okay. Now if you analyze the periodic table, we know that at the extreme left side of the periodic table, you can see metals, isn't it? First group, second group, they are completely metals. Transition elements, all of them are metals. Okay. And in between metals and non-metals, you can see a zigzag line. What are they? They are metalloids, isn't it? Like boron, arsenic, antimony, polonium, tellurium, etc. A zigzag line is coming and they are metalloids. And after metalloids, at the extreme right side of the periodic table, you can see that they are non-metals. Halogens and noble gases are completely non-metals. In between, some nitrogen, oxygen, etc. are also coming just before halogen family, isn't it? You can see the periodic table. You can analyze the periodic table. So you can say that at the left side, extreme left side, they are metals. So when you move from left to right across a period, what is happening? The metallic nature decreases, isn't it? First metals, then you can see metalloids, then at the right end of the periodic table you can see non-metals, isn't it? Okay. Now let us analyze what happens to metallic character when we move from top to bottom in a group and from left to right across a period. Okay. So let's take one group for example. So I'll take the first group, lithium, sodium, potassium, rubidium, etc. They are there. So I'll take lithium, sodium and potassium for example. We know that lithium is having electronic configuration 2,1 as its atomic number is 3. Sodium is having electronic configuration 281, atomic number 11. And potassium is having electronic configuration 2881, isn't it? So we know that the valence electrons remains the same. All of them are losing that one electron. Okay. Now see here what happens to the size of the atom. The size of the atom increases when you move from top to bottom in a group, because the number of shells increases when you move from one element to the next element in a group. Okay. For example, lithium, only 2 shells are there, while sodium is having 3 shells, potassium 4 shells are there. The next element will have 5 shells. So the size of the atom increases from top to bottom in a group as the number of shells are increasing. Okay. Now, is there any connection between the tendency to lose electron and atomic size? Yes, there is. You know that when the size of the atom gets bigger, the force of attraction from the nucleus to the last shell will decrease. As the size of the atom gets bigger, what will happen to the force of attraction from nucleus to the outermost electron? It will decrease because it is far away, isn't it? Okay. So what happens? The tendency to lose electron also will increase. Are you getting? So when the size of the atom gets bigger, a bigger atom can lose its electron very easily because the force of attraction from the nucleus to the last shell is less. Okay. So what happens here? When you move from top to bottom in a group, the tendency to lose electron increases as the number of shells increases and the force of attraction from the nucleus to the last electron decreases. Alright. So what happens to the metallic character? Metallic character means the ability to lose electrons. So we have found that when you move from top to bottom in a group, what happens? The tendency to lose electrons increases. Therefore, metallic character or metallic nature increases from top to bottom in a group. Is that clear? So we can write metallic nature increases from top to bottom in a group. Okay. Now let's see what happens to the metallic character when we move from left to right across a period. So we will take one example. Okay, now let me take the second period starting from lithium. Okay, so write lithium, fourth one beryllium, boron, carbon, nitrogen. So I'll write the atomic number 3, 4, 5, 6, 7, oxygen, fluorine and neon. Okay. So while finding the metallic character and the non-metallic character of elements, we are not considering the noble gases because we know that they are stable, they are monoatomic. A single atom can exist alone. Why? Because they have completely filled last shell electrons. They do not gain, lose or share electrons during a chemical reaction. They do not take part in any chemical reaction as they are stable in nature. Okay. So I am not going to write neon. We don't want neon. Okay. Now we are considering from lithium to fluorine and we are going to check how the metallic nature or the metallic character, or it is also called the electropositivity. Why it is called electropositivity? We know that metallic nature means the ability of an atom to lose electrons. Okay. So after losing electron, what it will become? It will become a positive ion, isn't it? For example, lithium, electronic configuration 2, 1. So what happens? It will lose that electron, making lithium a positive ion. That we already learned, isn't it? Okay. Why it became a positive ion? Because initially lithium is having 3 electrons and 3 protons. Okay. Now after losing 1 electron, now it has 2 electrons and 3 protons. 1 positive charge is extra in the atom now. So it became an ion. It is lithium plus 1 positive charge is extra. That we learned in 9th standard. Now let's write the electronic configuration and we will check what will happen to the metallic character or the electropositivity of elements from left to right across a period. Okay. So here the electronic configuration 2, 1. This is 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and 2, 7. Okay. Now from the electronic configuration, while discussing about the size of the atom, we understand that from left to right in a period, the atomic size decreases. Okay, why it decreases? Because in a period, the number of shells remains the same. In second period, there are only 2 shells present. But what happens to the effective nuclear charge? The effective nuclear charge will increase one by one as we move from left to right in a period as the atomic number increases. So as a result, the force of attraction from the nucleus to the last shell increases and the size of the atom decreases. That we already discussed when we discussed the atomic size of atoms when we move from left to right across a period. Okay. Now, we know that as the size of the atom gets smaller, the tendency to lose electron becomes weaker, isn't it? So what will happen? The metallic character decreases in a period. Are you getting? So to become a positive ion, the tendency to become a positive ion decreases as the size of the atom gets smaller in a period. Therefore, the metallic nature also decreases. That is why we can see its extreme left of the periodic table, all of them are metals, and while we moving to the right side of the periodic table, what happens? It will slowly become metalloids and then becomes non-metals. Okay, as the metallic character decreases across a period. Is that clear? Okay, so I'll write the metallic nature or the metallic character or the electropositivity decreases across a period. Okay. Now let's move to electronegativity or non-metallic nature. The fourth property is non-metallic nature or electronegativity. Okay, metallic nature we know that electropositivity or electropositive nature. Okay, and non-metallic nature means electronegativity or electronegative nature. Electronegativity. Okay, so let's understand what is non-metallic character or electronegativity. So when an atom becomes a negative ion, we know that when an atom gains an electron, it will become negatively charged, isn't it? For example, chlorine, we know that chlorine is having an atomic number 17, it is having an electronic configuration 287. So to get the octet, chlorine is gaining one more electron. So after gaining one electron, what happens? Chlorine will become a chloride ion, isn't it? So chlorine becomes chloride ion when it accepts or gains one more electron, isn't it? So that capacity, the ability of an atom to gain electron is called electronegativity, and the ability of an atom to lose electron is called electropositivity. Now we are going to check what will happen to electronegativity when we move from top to bottom in a group and from left to right across a period. Okay, so let's take an example as usual. The first order, any group you can take. For example, let me take halogens. They are non-metal. We are discussing about non-metallic nature, isn't it? So it is fluorine, chlorine, bromine, iodine, styrene, etc. Okay, atomic number of fluorine 9. Chlorine 17, bromine 35, etc. So the electronic configuration 2, 7, 2, 8, 7. Bromine you haven't learned, even then I am writing 2, 8, 18, 7. Okay, so the atomic number is 35. What is happening here? We know that the number of electrons in the outermost shell remains the same, while the number of shells increases one by one while moving from one element to the next in a group. Okay, so what is electronegativity? Electronegativity is the ability of an atom to gain electrons, isn't it? So here every atoms are Fluorine, chlorine, bromine, iodine, astatine, all of them are having 7 electrons in the last shell. All of them are gaining 1 more electrons to complete the octet. But the ability to attract the electron is varying. Can you say why? We know that when the atom gets smaller, what will happen? It will have enough effective nuclear charge to get or to attract the incoming electron very strongly towards the outer shell. Are you getting? Okay, smaller atoms are having more ability to or more force of attraction or strong force of attraction to attract the incoming electron very strongly towards it. Okay, because the nucleus is closer to the last shell. So which force of attraction is attracting the incoming electron? Definitely it is the protons in the nucleus. So as the size of the atom gets smaller, it can attract the incoming electron very strongly towards it. Okay. Now the ability of the atom to attract the incoming electron decreases as we move from top to bottom, as the size of the atom increases. Is it clear to you? Okay. Therefore, in a group from top to bottom, the electronegativity decreases. Okay. So the electronegativity decreases in a group as the size of the atom gets larger in a group from top to bottom. Is that clear? So what is happening here? Electronegativity decreases in a group. Okay. Now let's check what will happen to the electronegativity when we move from left to right across a period. Okay. Let's take the same period. Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. 3, 4, 5, 6, 7, 8 and 9. Okay. So what happens here? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 and 2, 7. What happens to the electronegativity? We know that the size of the atom gets smaller when we move from left to right across a period. Okay. Because the number of shells remains the same and the effective nuclear charge increases from one by one as we move across a period, that we already discussed. So as the size of the atom gets decreased, what happens? The ability of the atom to gain electron will increase. So here in this period, fluorine is having the most smallest atom, isn't it? Therefore, the ability of fluorine to gain one more electron is more stronger than any other elements in this period. Is that clear? That means in a period from left to right, electronegativity increases. Okay? The electronegativity increases across a period. Okay, now let me ask you a question. We know that electropositivity decreases in a period, okay, and increases in a group, okay. And electronegativity, okay, what happens? It will decreases in a group and increases in a period. The question is, which is the most electropositive atom in the periodic table? So we know that the most electropositive atom is francium, isn't it? So the extreme left side is more metallic in nature. So the first group elements are more metallic than any other elements, isn't it? And in that group, in that first group, we know that if we move from top to bottom in the group, the metallic nature increases. So the most electropositive atom is francium. And which is the most electronegative atom? We know that the electronegativity, okay, increases when you move from left to right across a period. And so halogens are more electronegative in nature. So among halogens, which is the most electronegative? So in that group, we know that electronegativity decreases when you move from top to bottom in a group. Okay, therefore the first one, when the top one, which is fluorine, that is the more electronegative atom. Now we have discussed how the properties vary in a group and also in a period. Okay, now just one more point to add, that is the metallic oxide, the nature of the metallic oxide. Okay, the metallic oxides are bases, we know that, and non-metallic oxides are acidic. Okay, so in a period, when you consider a periodic table, you know that the extreme left side of the periodic table is metals, isn't it? Okay, and the extreme right side of the periodic table is non-metals. Okay, so we know that metal oxides are basic in nature and non-metal oxides are acidic in nature. So what happens to the nature of the oxides when we move from left to right across a period? We know that the basic oxides will become acidic oxide as we move from left to right across a period. Okay, so hope today's class is clear to you. We have discussed only two properties and we have completed the lesson, and we will discuss the exercises in the coming class. Take care and bye-bye. Thank you for watching.